in the second part of 8, we're going to be looking at using the derivative to find the gradient of tangents. So we can think of dy dx is the gradient of a tangent if we have a curve. And we know how to find the derivative of any polynomial. So here's an example. We have a graph and we know it passes through 212. We need to find the equation of the normal at that point. We can't find the gradient of the normal straight away, but we can find the gradient of the tangent. We can do this by differentiating the curve. So if this is y, we can differentiate dy dx is 6x squared minus 10x. This is for all points on the curve, but we want to know the actual value at x equals 2 at the point P. So if we put 2 into this expression, we get the value 4. So we know at P the gradient is 4. But if the tangent has gradient 4, then we know the normal has gradient negative quarter, as these are perpendicular lines. So we now know that normal has gradient minus a quarter and goes through the point 212. Put these two facts into our formula for a straight line and rearrange, sketch the equation of the normal. Here is a typical exam question for you to try. Press pause, and once you've finished doing it, press play again to see the answers. Part A. We need to differentiate the expression for y. 3x squared minus 4x. The second part, we need to find the equation of the tangent. So we need to find the gradient when x is 2. We can do this by putting 2 into the derivative. We get the value 4. So we know the gradient is 4, but we don't have a point that the line goes through. But we do have an x value, and we do have an equation for the curve. So if we put 2 into the equation, we get the value y is 4. So we now know that the tangent has gradient 4 and passes through the point 2, 4. If we put this into the formula for our straight line, we can rearrange and get the equation for the tangent. We'll leave you with key points from this section.